So the particle effect itself shoots a cone of particles in its forward direction. That forward direction was oriented by the on-state update. I'm going to emit based on movement. I'll emit 5 per distance as the AI waves its arms. So as it's waving its arm, it's moving and it's emitting particles in a cone that points out towards my character. Now, in order to damage my character, I'm going to include a collisions module set to the world. And I'm going to also toggle its send collision messages. So the particle effect has a collision module and it's has its message triggered. So where's my prefab for the poofer? It has a collision module, and the collision module, well, that one doesn't. Maybe it's poofer 3. The collision module should have, well, one of them does it. Sorry. Let me find which poofer it is. It's poofer 2. So poofer 2 should have a collision module that has the send collision messages checked. Now, if we are sending collision messages, we can use that to damage the player. So I've put a health script on the player. It has an exposed variable health. And I'm going to modify that from my damage script, which I'll put on the poofer. And I'll also display this in my UI. I've got my little UI here that's going to display my current character's health. In update, it's just displaying the health and setting the slider value. And it's going to be assigned by the damage object health counter that I've put on the poofer prefab on the particle effect that has been instantiated. And it uses the on particle collision function when a particle with a collider, with a collision module on it, with that send collision message checked, will send a message to the on particle collision, returning the game object that the particle encounters. And if that game object is the player, I'm going to get the current health component that lives on my player, and I'm going to decrement the health of that script. So we have a script on our player, we have scripts on the particles, and the particles are calling the on particle collision and decrementing the health of my character. So all very cool. Let's see it work. I've started off, I think, with 1,000 points, 1,000 health. Takes forever to start. And he'll run away. He's searching, he's chasing. He's now close enough, he's jumping, and the particles are streaming out and hitting my player, and my points are going down 983 and so forth. So everything's working here. My AIs are damaging my player, and that's cool. When you're making guns, it's always good to use particles as the bullet instead of physical objects. It's much more efficient, uses the GPU instead of the CPU. We're not manifesting mesh objects, and it's particle bullets are actually a great way to go. I'm going to a few other minor modifications. One problem with AIs, if they all have the same target, they have a tendency to all take the same path, and so they end up lining up and not looking real random. And one way to overcome this is to add some randomness. And one of the problems was that the characters always rotated the same way. We used an idle turn right 45, so they were always turning to the right. A simple modification is to mirror that animation, the idle turn right 45. You can mirror it, and then a right turn becomes a left turn. And in our script, we can add a set mirror function that will be a parameter that will control the animation's mirror property. We can then add to our start function a set bool set mirror that has as its argument the Boolean random value is greater than 0.5. Random value is between 0 and 1, so half the time it'll be greater than 0.5, half the time it'll be less. And so we'll get left turns instead of right turns. And I believe that's here. Let's see. I have a turn left and a turn right, and in my idle state, I have these different clips: turn left, turn right. So so we can get this kind of behavior. One other thing that I can do to make it a little more random is to make the target fuzzier. So I can make the target fuzzier by calling a random number inside unit circle. This is going to return a vector 2 somewhere inside a unit circle surrounding our point. And so I can use that target offset that I used to put it in front of the character, but I can do this with a random distance. This is a scaling parameter for how big I want that fuzziness to be of the random x, random y that comes from inside the circle with a 0 in the y, and then that normalized so that it's 1, so that the scale of it is random distance. So my target offset that I use to target my position is offset in this way. I don't do this every frame. I do this every so often. And the way one might do this is to replace that kind of rigorous target position wanted direction with one that every so often creates a new random target offset. So we'll use the time clock here. Time is greater than random time, and random time is our current time plus the random time, which is how often we want to set this. So this won't trigger every time through through it, only when the time, a certain amount of time has passed, and then it makes a new target offset and sets a new end time for when it'll do another one. And then our target position adds in this offset, and wanted direction is the same as it was before. So now we have kind of fuzzier behavior of our targeting character. This is not the target for shooting bullets. This is the target for chasing our character. One other thing that I encountered was that with the line of sight that the AIs are using to search for my player, that they can't see through each other. So in this case where I was stress testing them, I had a whole bunch of them, and in this stress test, they wouldn't be able to see through each other. So they kind of the front row would be shooting at the character, but the ones behind it. Let me turn off gizmos here. The ones behind it wouldn't be able to see them. The stress test here was to see what the frame rate was. I am down around 12. I'm not sure how much of that is because I'm using Zoom at the same time. So the solution to that is to use one of the tools on the raycast, which has the ability to cull layers that it will ignore. Similar to the camera that we culled layers that the camera couldn't see, the raycast can cull layers that it will cast through. So I've added a custom layer to our AIs, and I've assigned all of them to that layer. And I've added an exposed variable AI layer of type layer mask to our script for the raycast. Now, in the inspector, this will show all of the different layers of my character. So this should have a layer. Here's the layer. And it has the usual kind of pull downs where you can select a layer that you want to be the one that is selected. So I've selected here the AI script. Now the problem is when you put the filter on your object, what you want is to select all the other layers that it can see. So we do a little trick using the reverse bit operation. So the AI layer is a 32-bit integer. So it's got 32 different zeros and ones. Is a layer mask. And when I set it to be AI, that puts a 1 in the slot that corresponds to the layer AI. And what I want for the raycast is to exclude that layer. So I actually want a 0 in the slot of the layer that I want to exclude. Well, the tilde operator reverses the bits of a number. So that AI layer that has a 1 in the bit location that corresponds to the AI layer, I reverse it, and now I have 1s in all the slots except the slot that corresponded to the AI layer, and I use that for culling in my raycast. This will now cull the slot that has the 0 in it, which is the bit reversed version of the AI layer that I set here. So all of that's pretty cool. And so now these guys don't see each other. And I believe this AI 6 is the one that has the full collision, the fuzzy collision, where they can see through each other, and they're all targeting my player and shooting the heck out of them. So all of that's good. And I can run away and they'll chase me, and I can run towards them and they'll flee. And I believe I can go over here and hide behind the wall. And most of them can't see me. Some of them can because they're over here. Okay, so very cool.